This topic will look at finding the mean value of a function over a given interval and look at real-life situations where this may be applicable. Let's start by considering a house whose value in 2012 was £120,000 and in 2017 the value was £180,000. If we assume that the price of the house has risen in a linear fashion, can we find the mean value of that house over that amount of time? So we can draw a graph here showing the two values. If we assume a linear increase, we have a straight line here. So the mean can be calculated by finding the total price over the amount of time. Now, because this is a continuous function, we can actually find the total by finding the area under the graph. This is similar to finding, for example, the area under a velocity time graph to find the distance that has been travelled. So if we were to find this as an area of a trapezium, we could say that over the course of those 5 years, we could in a way describe the total as being 750,000. If we then divide that by the number of years, we get a mean of £150,000. As you can see, what we've done here is we have assumed that the total price is just the price each year added together. Let's imagine now that the price of the house did not increase in a linear fashion and instead can be modelled using this quadratic equation, P equals 2,400 t squared. In this case, P is the price above 120,000 and T is the number of years after 2012. If we were to plot this function, we can see it's non-linear. So in this way, we could find the total price again by integrating the function. If we integrate the function from 0 to 5, and then divide the answer by 5, as this is the number of years, the integral is 100,000. 100,000 divided by 5 is 20,000. And because P was defined as being the price above 120,000, we can add the 20,000 onto 120,000, giving us an average price over that time of 140,000. This makes sense as it's slightly less than the average price when we were assuming it was linear, because the shape that we are modelling the price of the house, we can see that it starts off quite low and then increases later on. So the average value over those 5 years will be slightly lower than if it had been a straight line. So to calculate the mean value of a function, we can use this formula. By the mean value, we can think of that as being the average value of y over that interval. So we find the integral of the function from a to b, and we divide by the width of the interval, which will be b minus a. So here's an example. We're going to use the function f of x, and we're going to use the interval from 0 to 4. So the mean value, or the average value that y takes over that period of x from 1 to 4, can be found by integrating f of x from 1 to 4 and then dividing by 3. So we get 33 over 3, which is 11. So the average value of y over that period is 11. I'm now going to suppose that the velocity of an object at time t is given by the formula v equals t squared. So from this we can see that the velocity at time t would be 0 meters per second, and the velocity at time t is 3 would be 9 meters per second. However, because this is not a linear increase, we cannot assume that the average velocity will just be the average of the two endpoints, 0 plus 9 divided by 2. It will not be 4.5. Instead, we need to use the mean value formula to calculate the total distance travelled, which, as we know, is the area under a velocity time graph, and then divide by the amount of time taken. So the average velocity will be the integral of t squared from 0 to 3 divided by 3 minus 0. So we can see that the average velocity over this time period is not 4.5, but is in fact 3 meters per second. Now complete exercise 10B on page 230.